Hi everyone, and in this video we are going to be talking about section 3.5 from your text. And 3.5 has a lot of things in it like 5-number summary, interquartile range, or IQR, and also a box and whisker plot, or maybe just box plot as we like to refer to it. So it should be a nice short little video. The 5-number summary is these 5 numbers that you can get from your data set. And in order, we're talking about the minimum, the first quartile, the median, the third quartile, and the maximum. So remember, the first quartile we might use Q with subscript 1 to represent that. The median we use X tilde to represent the median. And the third quartile we use capital Q with a subscript 3 to talk about third quartile. So let's consider this data set in our discussion of the 5-number summary. And we'll show you how to get these 5 numbers from this data set. Step number 1 would be to take this data set up here and just put it in order from like least to greatest, for example. And so this is what it looks like if we, take each part of our data set and then we actually place it in order from least to greatest. So maybe it takes some time to do this, but at least it's already done for me. And then we're going to identify the maximum, the minimum, and the median. And so this is not too hard to do. So of course the minimum is going to be that number, the least number. Maximum is over here on the right side. And then the median is in the middle. So for the median, we first have to count how many we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I've got 13 numbers. That means the 7th one is going to be in the middle. 1, 2, 3, 4, 5, 6, 7. This is going to be my median right here. 11.7. So I've got 6 numbers on either side of my median. So that 11.7 measurement, that's the one in the middle. Now the first quartile is the median of the lower half. That's actually not that bad to find, because what I have to do is just take the lower half here and then say, what's my median? Well, my median would be the middle of these 7 numbers. And so for my first quartile, boom, found it. And likewise, the third quartile will be the median of the upper half. So for this third quartile, I just have to look at the upper half of these numbers. Say, okay, out of these 7 numbers in the upper half, what's in the middle? Well, it'll be 13.6. So there's my third quartile. So hopefully you see how to find the first and third quartile. Although I kind of glossed over this fact so far, but I'll mention it. Quartiles can either be inclusive or exclusive. And so inclusive means you include the median in the half of the numbers that you're considering, and exclusive means that you always exclude the median. And so what I just did, if you remember, I actually included the median as I was finding the first and third quartile. If I wanted to exclude the median when I found the third quartile, you could do this and only consider the upper half of the numbers, but not considering the median, and they actually have 2 numbers in the middle. And of course, to find the median, if you have an even number of numbers that you're considering, we take 13.6 plus 14.3, divide by 2, and we're going to find that that's going to be 13.95. So this would be the third quartile exclusive. And in green, we would have the third quartile inclusive. So if you included the median, you would actually find the third quartile was 13.6. Notice for the first quartile, whether it was inclusive or exclusive, the first quartile was just bound to be 9.6 either way. And again, here where I've identified 9.6 and 13.6, that would have been inclusive. Okay, so whenever you see IQR, this stands for interquartile range. And the interquartile range just means the third quartile minus the first quartile. So for us, this is 13.6 minus 9.6. And again, the IQR is going to depend on whether or not you chose your quartiles including the median or excluding the median. I personally don't care. I just want you to actually specify on your paper whether you chose to be inclusive or exclusive towards your median whenever you're choosing your quartiles. But it looks like this interquartile range is going to be the number 4. So my IQR is 4 here. Now the interquartile range, the IQR, it's a measure of dispersion. Just like range was a measure of dispersion, if your first and third quartile are farther apart, then you're looking at a more dispersed data set. Other measures of dispersion were range, variance, and standard deviation. IQR is just another descriptive statistic that gives you a sense of how dispersed your data set is. IQR is better than range because IQR ignores the outliers, right? You're not actually considering the very maximum value and the very minimum value. But it's not considering every single data point the way that variance and standard deviation do. So IQR has its pros and cons. One of the pros being that it actually ignores really bad outliers, if that's something you want in a measure of dispersion. So the last thing we'll talk about is how to make a box plot. And so here's a stepwise procedure. First, we calculate the 5-number summary. So it's the min, first quartile, median, third quartile, maximum, and the IQR. We're going to calculate what's called the upper fence and the lower fence. And so the upper fence and the lower fence, I have formulas for these right here. Please, I would say please memorize these, but I think they're actually on our formula chart. By the way, if you want the formula chart, if you go to our Canvas course homepage and you look under course information, you can see this link to nice comprehensive formula chart. If we click that, this is what I'm talking about. This is the formula chart that you're going to have on every one of your exams this semester. So this is what I'm going to allow you to use. And if you want to know how do you calculate upper fence and lower fence in IQR, it actually is here on the very first page under chapter 3. So we can see lower and upper fences just like that. And that's what you'll be able to use on your exam. So actually take a look through this formula chart and make sure that you see what's on it and that you're familiar with where to find everything, because you're going to want to be able to be familiar with that prior to your exam. So we're actually going to start drawing in step 3. We're going to draw a box around the first and third quartile with a special line for the median. We're going to draw whiskers that extend to the most extreme values inside the fences. This is very important 3 words. The whiskers only go inside the fences, and we mark outliers with an asterisk. So I'm going to box plot for this data. And so first I've got to put these things in order from least to greatest, and it looks like the smallest number I see so far is 4.6. And then the next smallest number looks like 7.2. And the next smallest number is going to be 8.6. And the next smallest is 9.5. And then I have 10.2. And then I have 11.4 and 11.5. Then it looks like 12.4, 13.5, and I forgot 12.2. So right here is where 12.2 goes. And then it looks like my last numbers are 16, 19.3, and 21.4. So this is my data in order from least to greatest. And that's all of them. Let me count how many I had. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 measurements in this data set. And to find the median would be the 7th one. So 1, 2, 3, 4, 5, 6, 7. It looks like the median is going to be 11.5, doesn't it? Yeah, because I've got 6 measurements that are less than 11.5 and 6 measurements that are greater than 11.5. So here's my median. My minimum is going to be 4.6. My maximum is 21.4. My first quartile, I'm going to just choose the inclusive because that's going to be easier. It won't require me to average any numbers. So this is my Q1 that I found, including the mean in the lower half of the numbers. And then including the mean in the upper half of the numbers, it looks like 13.5 would be my third quartile inclusive. You can calculate these exclusive, but then it requires you to take an average. I just don't feel like doing that, so I'm just going to tell you I'm selecting my quartiles inclusive of the median, and that's totally fine. Okay, so then after I've found my 5-number summary, I'm going to draw a little number line here. And I'm going to make sure that my number line is scaled so that I am including the minimum and including the maximum here. And so maybe I scale it from 0 to 30, so the midpoint would be like 15, and then I need 20 and 25 in here, and then 10 and 5. So I've got a little number line going on. I'll calculate my interquartile range while I'm at it, so that's going to be the third quartile minus the first. It's 13.5 minus 9.5, which is 4. The lower fence, what is my lower fence? Right, so you can go back and check that formula. But my lower fence is the first quartile minus 1.5 times the IQR. Now 1.5 times the IQR is going to be 6, because 1.5 times 4 is 6. And then the first quartile is 9.5, so 9.5 minus 6, that's going to be 3.5. The upper fence is similar, third quartile plus 6, because it would be plus 1.5 times the IQR. And so that's going to be 13.5, that's going to be 19.5 for my upper fence here. Make sure you're following along with these examples and doing them yourself so you understand what you were doing here. I'm going to draw a box, hence the word box plot, where the left side of my box is going to be at the first quartile, so it's going to be at 9.5, just below 10. And then the right side of my box is going to be at the third quartile, which is at 13.5, which is over here somewhere. I'm going to connect up this box with a nice top of the box and bottom of the box. I'm going to put a little vertical line where my median is. My median is at 11.5, so I think my median should be somewhere around here. And you don't have to label these. These are implied, what they are, by the way you constructed the box. This would be first quartile, median, third quartile, just to show you what that box represents. Then we're going to draw whiskers out to the most extreme values that are still inside the fences. So my lower fence being 3.5, the most extreme value on the low end that's still within the lower fence would be 4.6. So 4.6 is my minimum value. I'm going to draw a whisker out to that minimum value. It's the most extreme value that still falls inside my lower fence. What's the most extreme maximum value I have? It would be 21.4. Let me put a dot where 21.4 would be on this number line. Is that inside my upper fence? Well, no. 21.4 is not inside my upper fence. Actually, the most extreme value that is inside the upper fence would be 19.3. So I'll put another dot where 19.3 is, and I'll actually draw the whisker out to 19.3, because the whiskers don't leave the fences. If you have a number that's outside of the fences, we use a dot to designate outliers. Or I think maybe I put on the previous slide that we use asterisks. So maybe we use an asterisk at that maximum value of 21.4 to note that you had an outlier. And by the way, I mean, you can have more than one outlier, right? Like maybe if I had another data measurement that was like 27, I'd put an outlier over here. If I had a measurement that was just number 1, you can add more outliers. So you can have way more than one outlier. But in this case, we only had one outlier, where we're talking about outliers as numbers that are outside of our fences. So if it was less than 3.5 or greater than 19.5, that's what makes an outlier an outlier. Anyways, this green in by the way, in combination with the number line, because you really need the number line to interpret a box plot. If I ask you to draw a box plot on an exam, I'm expecting you to draw both the number line and the box and the whiskers and the line for the median and the asterisk for the outliers, all correctly positioned above the number line. So, all right, that's it. Short video for the end of this week. Thank you guys.